The types of planes is a rectangular plane of whose dimension is a 30 millimeter and this length is a 40 millimeter. This is a square of the size 30 millimeter. This is a rhombus which is specified by its diagonals. Longer diagonal is of a 50 millimeter and smaller diagonal is of a 30 millimeter. This is a trapezium of which the parallel sides are 30 and 40 millimeter, whereas the distance between these parallel lines is of 30 millimeter. Then is a triangles, equilateral triangle having all these three sides of equal dimensions. Isosceles triangle of which base is 30 millimeter and these two sides are of equal length, and this will indicate its altitude which is of 40 millimeter. 30 degree set square which we are using in our engineering drawing. So this is angle of 60 degree and this is of 30 degree, so it is called as a 30-60 degree set square. Then next is a hexagon which have the 6 sides having side length of 25 millimeter. Pentagon having 5 sides each length of 25 millimeter, and this is a circle. So we have to study all these different types of planes in our engineering drawing.
Of a plane with respect to HP and PP. So here the vertical plane and horizontal plane is given, which are at right angle to each other. The intersection of PP and HP is called as a reference axis, and the plane which we have considered is a rectangular plane, which is shown in red color of a dimension of 40 and this length is of 60 millimeter. Now this is a case in which this rectangle is parallel to HP and perpendicular to AP. We have to draw its front view and top view. Its front view appears as like this one. Here the front view appears as a straight line which is parallel to the XY, and its top view appears as like this one. So the top view appears as a rectangle which will indicate the true shape of a given plane. In conclusion, when the plane is parallel to HP, and perpendicular to VP, its front view appears as a straight line which is a parallel to this XY line, and top view appears as a true shape of a given plane which appears on horizontal plane. Now consider the second case. Now in this case, the given rectangular plane is perpendicular to both VP and HP. If you observe, its two views. Is the front view appears as a straight line and which is at a right angle to the XY. Now for front view, if we observe from top side, then its top view appears as a straight line which is again perpendicular to XY. So in conclusion, when given plane is perpendicular to VP and HP, then its front view and top view shows a line view which is at a right angle to the XY. Its true shape view will appear along the side plane as like this one. So side view will appear as like this one, which it shows its true shape. Now consider the third case. In which the given rectangular plane is a parallel to VP and perpendicular to HP, and its front view appears as like this one, means front view shows its true shape, whereas top view appears as like this one, is the top view shows a line view which is a parallel to the XY. In conclusion, when a given rectangular plane is a parallel to VP and perpendicular to HP, then its front view shows its true shape and top view shows its line. So if you consider all these three planes, so in first case, front view appears as like this one. In this case, the rectangular plane is parallel to the HP. In this case, it is a perpendicular to HP, and in this case, it is a parallel to VP. In top view, it shows its true shape as it is a parallel to HP and perpendicular to VP. In this case, it is a perpendicular to both planes, and in this case, it is a parallel to VP and perpendicular to HP. So all three views are clear here.
Let us let us study the different positions of a different plane with respect to vertical plane and horizontal plane. In projection of planes in problem statement, generally the data given contains the resting condition and inclination with respect to HP or VP. Here consider the first case. that the rectangular plane is given. Such type of the rectangular plane is given, of which the edge rests on horizontal plane, provided that this edge must be perpendicular to xy or to VP. Now the plane is inclined to HP at a given angle, that is theta, and this plane is a perpendicular to VP. This is a final condition, and we have to draw its front view and top view. Next, such type of the square plane is given, of which the corner is resting on vertical plane. This plane is a perpendicular to HP. This, if you observe from the top side, as it gives the top view as a line view, so we can say that it is inclined to VP and it is a perpendicular to HP. Third case, a hexagon is given, of which one of the corner is resting on HP. This hexagonal plane is a perpendicular to VP. As it is a perpendicular to VP, in front view its line view appears, whereas in top view it gives such a apparent shape because we are considering this hexagonal plane in inclined position to HP. Now consider the fourth case. Again here hexagonal plane is considered. Now this hexagonal plane is resting on VP on one of its edge. It is resting on one of its edge. This plane is inclined to VP. Means if you observe its top view, we can conclude that this hexagonal plane is inclined to VP and it is a perpendicular to horizontal plane, that is HP. So if we consider all these four cases, first observe the front view. This is a rectangular plane which is inclined to HP and perpendicular to VP. This is a square plane which is inclined to VP and perpendicular to HP. This is a hexagon which is resting on one of its edge on HP. It is inclined to HP at a given angle and it is a perpendicular to VP. This is a hexagon which is resting on VP on one of its edge and it is a perpendicular to HP and inclined to VP. Observe the top view. Perpendicular to VP, inclined to HP, inclined to VP, perpendicular to HP, inclined to HP and perpendicular to VP, inclined to VP and perpendicular to HP. So these are the different cases which will show the resting position and orientation of these plane with respect to VP and HP.